Hello and welcome to the next part of the initiative. In this video we will continue using the Pi3b Plus and build our first image using Docker. I will briefly discuss containerization, Docker, Dockerhub, build our first image, run the image as a container, tag and push the image. Let's get started. Alright guys, let's begin. Now we're going to start talking about containerization first. And just to give you a quick summary, containerization is a process of running applications inside a container. And unlike virtual machines, it doesn't require extra hardware. As you can see in my Medium article, which I will link in the description, this is pretty much what I talk about here. So, now just to give you an idea, with virtualization, you will need more RAM, powerful CPU, and storage. So I'll show you rather than just simply tell you. So here is an image with two different PCs. You have the OS, then you have virtual machine software. Now this could be VirtualBox or VMware. Then here we have two simple virtual machines, and they can run these different applications. But with Docker, you don't have virtual machine software, you have the Docker engine, or if you're using Docker desktop. Then you have your two containers, and then you have your applications running on each one. Now it's a lot more complicated than this, but I wanted to simplify things for you guys. Now the reason we're using containerization on the Pi, it's because we have enough resources for it, and we don't have enough for it if we wanted to do virtualization in this case. And plus, a Pi 3 is really not a good idea for any kind of virtualization, or should I say, it's not a good device to be using for virtualization anyways. So that's what we're going to do in this video. So now let's move on to Docker. Alright, so let's talk about Docker. Now Docker is containerization software that is used to run containers inside a host, as I mentioned in this image here. So in this case we're going to be using Docker. Now here I talk about Dockerfile. Now the Dockerfile is a file that will be needed to build our image. I'll talk more about this when we get to the demonstration. And yes, I've covered this before in previous videos, but I figure for 2026 that I give you guys an update. Not much has changed since I did my series of videos on that, and again I will provide that playlist in the description, and I will also provide it at the end of this video. But this is for those who haven't used Docker for a while or would like an updated tutorial on it. Now, one Docker file is fine if you are building a very simple application, which is what we're going to do. Now, as I say here, for more complicated applications, you will need multiple Docker files, for example, for your web server, database server, or email server. Now, I'll talk more about the process here, but here I talk about how each container has a unique ID, and that they can run at the same time as long as they use different port addresses. So we'll be doing that. Now, in this case, we will be installing Docker Engine, since we don't have a desktop and we want to use the very little RAM that we have on our Pi. So this is our website here, where you can find Docker. Now if you want to use Docker desktop, for example, on your PC, it shows you how to do that, but we won't be doing that since we actually want to get Docker Engine installed. So I will go to one of my bookmarks, and if we go to here, I will explain more about this process when we get to this. So I will talk about how to install Docker Engine on Debian ARM 64-bit, since the 32-bit version of the 32-bit version on Raspberry Pi OS will no longer be available. So we'll be covering this later on. So let's move on to Dockerhub. Alright, let's talk about Dockerhub. Now, to summarize, Dockerhub is a repository service where you can host your images publicly. It's similar to using GitHub, for example. So it's right here. Now I have a GitHub, I already have a Dockerhub account, and you will need one for this specific video. Now, here are some examples of images that are hosted on Dockerhub for Python, Redis, TensorFlow, PyTorch. These are, by the way, used for AI. BusyBox, which is a minimal form of Linux, Alpine, Nginx, and so on. So the way it works here, and I explained this in the article, is you build your image, and then I forgot to mention it here, but you can tag your image and then push it to a repository, and then pull the image if you want to run it somewhere else. And of course, you can use this for specifically if you want to reference your Docker image in a Kubernetes manifest file, which I have covered in the past, which again, you can check out my old videos on that. And we will be using Dockerhub here, so make sure you have a Dockerhub account here, and it's free, so you shouldn't have to worry about that. You only have to pay for the private images. So there's not much to say on that, so let's get to the installation process. Alright folks, so let's install Docker. Now of course I've already installed it on my Pi 3, my Pi 3B Plus, but in case you haven't, you should follow the instructions. Now a bit of warning. According to the website, it says here Docker, it says Raspberry Pi OS 32-bit ARM-HF depreciation. And according to this, it says that Docker Engine version 28 will be the last major version to support the ARM-HF version of Raspberry Pi OS 32-bit. So basically the Pi 0. And this also includes the Model A, Model B, Model A+, Model B+, and the Pi 0. Now, it recommends that since version 29 will have these packages, use 64-bit ARM, which we're going to do, or 32-bit ARM v7. However, since we have 64-bit installed, we can just go to the Debian installation instructions here. And to make things easier, just use the convenience script. Now, this will work with either Trixie or Bookworm, but we really want to use it with Trixie. So again, go to the convenience script and just follow the instructions there. I'll link the instructions on the description, or you can also use my Medium article here. So basically, curl the link, run the script here with this command, and then add the group Docker by using this command, and then add your username to the group Docker. Now, this is important because after this, you will have to log out with exit. Now, this is important because if you don't, it won't work. And then you can log back in again. Now, run this command to make sure it runs. So, in this case, I already have the Pi ready with Docker. So, I will run hello world. I'm just going to wait for it to run. Now, note, see? And it tells you the message shows that your installation appears to be working correctly. Note that if you get the same thing here, then you're ready to go. If not, you'll have to log out and make sure that you logged in correctly. And then we'll check Docker version to make sure it's the correct one. So we'll go Docker version, and there you go. And you can see it says ARM64. And again, this is the Debian version, the 64-bit ARM version, and it works on Raspberry Pi OS, so that's great. So now you don't have to rely on 32-bit anymore. So if you were building, for example, a Docker swarm with these things, you can now use 64-bit Pi OS and the 64-bit version of Docker. So, as you guys can see, I have a basic example that we're going to try next. So, let's get to that. Alright, so we're going to build our image here. Now, I already did this with the Medium article, but we're going to make our own here. So in this case, we have our files on the Pi. So I'm going to go to, I'm going to clear all this, ls. So we go to cd app, and we have 3 files: Docker file, app.py, and requirements.txt. So again, I did this in previous videos, so I will link those in the description if you'd like to check them out. So first we have our basic Hello World Flask application. So it's very simple. All it does is just print Hello World to the browser. Now you need to add this here because otherwise it won't be exposed publicly and we won't be able to run it. So you need to add this. And then of course we have our simple requirements file where we only need Flask version 3.1.3. And then we have our Docker file. Now the Docker file is already here, but as you can see, so if we go to, it's already here, but I will show it to you here as well. So there are some changes I had to make, and mostly it's just changing to a new Python version. So here we do from, and in this version we're going to create a Python 3.13 Slim version, which is the more recent version. Previously I was using Python 3.8, but this time I decided to use a much newer version. In fact, I will start updating my other projects using this version. Then of course we copy all the files within the working directory to an app directory. Then we make the app directory our working directory. Then we run this command here to install all the requirements in our requirements.txt file, so essentially all our libraries, and there's only one, which is Flask. And then cmd simply means we're going to run this command here, and make sure you separate the comma, and also make sure you have quotes around each part of the command. And that's really it. That's all the files we need, and remember, this is a simple example. So let's run it. Now we're going to name it differently as opposed to here. You can use this one if you want, but I'm going to name it differently to distinguish from the other one I already created. So we're going to do Docker build T, and we're going to call it something else. Let's call it YouTube Hello, and we'll use the current directory that it's in, and then we'll wait for it to build. Now I already built a previous image, but if you hadn't, it'll take some time. But since I already built an image with Python 3.13, it shouldn't take too long. So let's wait for it. Alright, shouldn't take too long. And there you go. You can see the files printing. Well, you can see all the libraries being installed. Now we're getting exporting to image. We're exporting the layers. And as you can see, we're now unpacking. And there you go. Now let's check that the images exist. I forgot to show you this in the article, but do Docker images. And there you go. So I already created one called Python Hello, and I tagged one with new Hello. We're going to use the same one. And then we have YouTube Hello with the latest tag. And notice it's a small file. Well, relatively small because we're using Slim. Now let's run the file, shall we? Let's run the image. So we'll do Docker run, then detached at port, such as DNP, and we need to use 5000, and then we expose it to 5000, and we'll do YouTube. Sorry, YouTube Hello. So let's do that. Okay, that right there is the name of the container that we created. So we'll do Docker PS, just to check. I forgot to show that there. And there you go. So this is the container ID, and here is the ID. And then of course it says up 9 seconds ago, up 9 seconds ago, and status is up 8 seconds ago. Oh, and the name here is Inspiring Hellman. This is just a name that they give containers. So to check that it works, we can actually do this. So we'll do curl. Actually, let's do it outside, so we'll split horizontally. So we'll do curl, and we'll do 192.1 168.1.99. I already checked the IP address of the Pi, and we'll do 5,000. See? Or, if you like, you can also check here. I already did this before, and there it is. So, you can use either one. Now, let's stop. So, oh yeah, and of course, make sure you do check that your container is running with Docker PS, because if it's not, then something happened. Now let's stop the container. Let me close this here, and we can do this by doing Docker stop, and we're going to copy this container ID right here, paste, and we'll just let it stop. There we go. Now we are done with running the application. However, now let's tag and push our image in the next segment. Alright folks, it's time to tag and push the image. So before we do that, this is my Dockerhub repository. I have quite a few here that I haven't used in a while, and here is the new one that I used before. So we'll be using this one. Now if you want to create your own, just click here on create repository. Create a repository name. You can give it a short description and create. Note that you can create one private repository, then after that you have to upgrade your plan. But we're not going to be creating a new one. So, at least for myself, you can create one if you want. But in this one, I'm just going to use mine. Now, you can use this one if you like as well. It's just a simple repository. So again, if you want to create one, you certainly can. And of course, you can also use the same name I did here, which is Python new hello. Alright, so first thing we're going to do is we're going to tag the image. Now, I use Python hello, but we're going to be using the other one. So we're going to use Docker tag and then YouTube. We're going to create a new tag this time. So we'll do use, and we're going to create a new tag. We're going to call it V2. Now you can keep it as latest, but V2 will be for me, and you can continue tagging it as much as you want. So let's do that here. And we already did it. So now let's push it to Dockerhub. Now, this command will have to be run if you haven't logged into the terminal. But I already did, and we'll be pushing it now. Now, if you haven't, just put in Docker login, and it'll send you to a browser where you will log in. You will add a code that it will give you. You paste it there, then log in, and you should be good to go. So now let's push the image. So we'll Docker push, and then we'll do V2, and it's going to take some time, so we will let it run. Now, when it says already exists in this case, that simply means that I already created an image similar to this, but it's simply just recreating them again. So that's it. Now let's go to my repository. If I reload, you can see it says V2, less than 1 day, and then less than a minute when it was pushed. So when you create new tags, the tag will be here. Now if you're using Windows, it'll have the Windows logo. Now it says here ARM64. And that's because we created it with the Raspberry Pi 3B Plus running the 64-bit ARM version of PiOS and running the 64-bit ARM version of Docker. So as you can see, we did it. We pushed our first Flask image onto Dockerhub. Alright guys, so I wanted to make this quick video update on this one because I had forgotten to do a test on the last video, so we'll do it here. It's an events-based test, so I'll show you what I mean. So it's the same sysbench CPU test, except we add time equals 0 and events equals 10,000. So it will have the 10,000 events. So let's run it on my main PC first. So just to give you a benchmark, I had forgotten about this, but I have updated it in the description, the article, so you guys can check that out. So I'm going to do this in real time. Okay, so 16 seconds. So let's compare this to the Pi 3. So we'll have the same one. And again, I will post the results in the, well, I'll post the updated tests in the description from the last article from the previous video. So I figure I'd put it in this video rather than try to update the last one. Okay, 8.9095 seconds. So that's, I would say, 50 times faster than this one. And I did test it on the Celeron G3930 and I got about 13 seconds. So just on raw CPU power alone, the Pi 3 is easily faster than either of my main PCs. So that's it for this test, and let's get back to the video. Alright folks, so in this video we learned a bit about containerization, Dockerhub, we installed Docker on the Pi, and did a basic demo with a simple Flask app. Next time I will show you how to turn your Pi into a camera. Until next time.